Alrighty, guys. So we're gonna look through the get you guys done with the forecast. I talked about last lecture. We went over weather modeling and how putting together a forecast based on models has its own issues, its own problems. You can run into your own hurdles and the old trash in, trash out. Well, we're going to take a look at a forecast. We're going to see just how good or bad some of the model data is. I'm going to try and walk you guys through a couple of different things. Now, we're going to do this a little differently than you guys would normally put together your actual forecast. I'm going to be asking you guys for something. Don't judge me that I'm drinking another one of these. I'm gonna walk you guys through the forecast a little differently than you guys will actually be doing a forecast for class, but hopefully it still makes sense. And we'll go through other weather forecasts too, so don't think that this is the only example you're going to get before I let you guys loose. But I think this is a good start to where we're headed. Okay, for example, here we are. We're going to do a forecast for Amarillo, Texas, because you guys know how much I love the high plains. The forecast is for 2 days into the future. We're going to say that we're on the midnight shift on November 29th, and we are going to take a look at the current conditions. Now, here's a look at the satellite currently. This is, again, if we're sitting at the midnight shift, you've got a cluster of convection moving through parts of Oklahoma, Kansas, and getting into Missouri and Arkansas. We got a whole cluster of junk back over here. A little area of low pressure to the north, some showers and thunderstorms off the coast of Florida, and what looks like kind of maybe a lingering frontal boundary kind of in here. Maybe an area of low pressure here, and kind of a lingering little boundary, and then maybe another area of low pressure down here. Who knows what this is? This could just be a cluster of storms, or it could be an area of low pressure. Okay. How are we looking on? Up at 300 millibars. Okay, so we got pretty close. You know, a little area of low pressure up here, a little area of low pressure right there, a little area of low pressure here, maybe another one down here. It's probably up here. But we've got, as we look at the jet stream well off to the north, except for our little cutoff low here, currently, Amarillo, Texas, right here, is dealing with a northwest flow and convergence happening on the back side. So here's your trough, remember, you've got convergence happening on the left side of the trough here. You've got, no, let me do that again. Need to release the buttons first. You've got convergence happening here. You're on the left side of the trough. You're coming through like that. So you're dealing with what kind of vorticity, positive or negative vorticity. Again, if you're crossing from left to right, think back to the old lectures. Probably negative vorticity happening because you're not curving. I guess you're kind of curving around, but you're coming off of, the point is you're coming off of a ridge. You've got positive going into negative, but you're mainly positive because you're going around this little ridge here and into this trough there. All right. Down, we look down at 5. So here's 300. We look down at 500. This is from the wrap. This is from the HER. Notice, look at all this area that is outside of the domain up here. All of this area is outside of the HER's domain. It was inside the domain, well, most of it, for the wrap. Outside of the domain for the HER. That's just a little nugget. That's not, you know. That's just a little piece of information. Oh, good. I froze up here again, didn't I? Okay, hold on a second. That's just a little nugget for you guys. We'll take another peek outside. It's kind of dark and gloomy out there. And then, so down at 500, I should say. Hold on, let me turn my little clicker back on here. So we're still ridge just off. So we got a trough, and we got a little bit of a ridge. It's not really much of a ridge. And then we got another trough in here. We got one up here, and then another one here. Okay, and that should line up pretty well with kind of what we're seeing here, right? I mean, that all of this makes sense, right? You know, you've got a little bit of a trough action, and then yeah, you got some cloud cover because again, you get divergence. You get divergence out here, and you should start to see some cloud cover develop. And then you come in here and you say, okay, well, yeah, we actually do kind of have a little bit happening. Surface, by the way, you've got northwest wind across the Texas Panhandle. Okay, let's get down here. It's okay, yeah, we're down at the surface, a northwest wind. You can kind of get an idea that you're dealing with a northwest flow, northwest flow, northerly. But then you come back around up here, and it gets a little more variable to the north. And of course, we're out in the mountains over here, so that's going to be reasonably variable as well. The current temperature, and we zoom into that real far if we really wanted to, but I believe should be about 58 degrees. Should be. Okay. Now, let's look at the model data. How about that? And what are we looking for? Remember our checklist. And we're going to do things a little bit differently. I didn't add in all of the information in here. But, again, here's all of the checklist, and we can cross-examine the data. We haven't had to do this yet, but this is coming. This cross-examination of the data. So you guys know about finding all of this information. We just did this on the last assignment. We also had to find other information that's actually not on this list too. In the future, you're going to have to cross-examine the data, which is you're going to have to find if divergence aloft at 300 millibars is happening over the top of 850 millibar warm air advection. Same thing at 500 over warm air advection. The wind speed and direction versus 850 millibars. Do we have vorticity near vertical velocity at 700, from 500 to 700? At 700, is there a what's called the dew point depression? Remember we talked about that earlier in the semester. Is the temperature to dew point spread, that dew point depression, greater or less than or equal to what's happening at 850 millibars? Is there vertical velocity happening at 700 millibars in the same area over top 850 millibar warm air advection? And down at 850, is the temperature dew point spread bigger or smaller compared to 925? You're just basically, you're looking top down and making comparisons and pulling out different data. You're cross-examining the data to double check and see what it is that you're looking for. And remember the parameters to consider. Now these numbers are more for South Mississippi, the Southeast, the Gulf Coast. However, we're just going to use these for Amarillo too. They're not the same for Amarillo. That's a guarantee. But nevertheless, we're going to use these. Okay. Here we go. So what do we got? We're going to look forward in time. Again, we're going to look... Yeah, I lost my little drawer, didn't I? Okay. So here's Friday at 18Z. Because remember, let me go back up here. Let me clear that off. Remember, we're looking 2 days into the future, into the afternoon. So we're on the 29th, the 30th, and the 1st. Get down here at 18Z. Because we want to do in the afternoon. So we're Friday at 18Z. So what do we have now? Well, we've got our little area of low pressure that's kind of moved into the desert southwest, which leaves a little bit of very slight ridging and some very slight, I would say very slight divergence just barely to the west of Amarillo. We'll have to see if that comes into play. Currently, 500 millibar height anomaly, we're running a lot higher, which means we probably have warmer air either beneath that or within that same region. Again, height anomalies, the height is relative to temperature because temperature and pressure are related. The higher the temperature, you got to spread out all of that air to fill that void. If we move down to the 500 millibar, so that was 300. We're up at 300. So 300 divergence, barely just off to the west. Now we're down at 500, and that's that area of low pressure, that troughiness off to the west is a little more pronounced in here. We've got maybe a little bit more divergence happening, perhaps a little bit closer. You can kind of make the comparison from here to here and say, okay, yeah, I think we've got maybe just a little bit. We've got some vorticity happening, but it's real stretched out, right? So we've got our vorticity in here. but then it kind of stretches out and across parts of the southern tier of the United States. So I would say that we've got, that'd be a wind of about 30 to 40 knots straight out of the west. If we're down at 700 and looking at the temperatures, if we were to make a comparison to what we see down here, you would say somewhere between about 0 and 5 degrees. You've got a little bit of humidity, not a ton in here. Your relative humidity is probably sitting in that kind of 50 to 60 and kind of 40 to 50 to 60% range. Going down a little bit further at 150, if we were to make a comparison, we're probably talking about somewhere between 5 to 10 degrees to maybe up to 12 degrees at 850. It's reasonably dry, but look at where the plume of richer moisture is. So you follow the wind barbs here with me. They're going to come in across parts of Mexico. They're going to kind of go up the east bank of the Rockies in Mexico, and they're going to kind of circle around and kind of curlicue back off that direction. This area probably just got an injection of dry air back in behind a front that's probably just off the coast. So you've got air that's come down this way recently. Currently, the wind is going across this direction. But for us, down here in Amarillo, we've got a wind it's trying to push more moist air up into our area, but I would argue that for Amarillo, we haven't quite gotten our 850 millibar dew point terribly high yet. I think we're still running in that 0 to 5 range, which, when the temperature is 5 to 15, isn't terrible. At 925, we're a little bit warmer. You can see temperatures, somewhere between about 10 to 15 to 20 degrees. And the wind is coming back out of the kind of southwest here. So we probably have a downslope component drying out some of the lower levels of the air. And precipitable water, you can see that we have some to the south of where Amarillo is. We still have some. I mean, our values are, maybe kind of in the 1 inch range, trying to get toward the 1 inch range. Or excuse me, toward the 3/4 of an inch to 1 inch range. And then your surface dew point in here, in Lubbock, it's a little bit higher in the 40s, but for Amarillo, we're hanging out in the 30s. So reasonably dry. So then we go and we look at our SKU-T. And you can see in here that our temperatures in the mid-50s, remember we were talking about that from 2 days ago, but we're now in the mid-50s at 18Z, so into the afternoon. So if we wanted to know what the afternoon high temperature was, 18Z at noon isn't going to give it to us. The noon temperature is not the high temperature for that day, and you can kind of see in some of our streamlines we've got wind coming up. So we've got to find a high temperature. There's 18Z, and then there's 0Z, somewhere between 57 and 57 degrees. Well, wait a second. Does that mean that the temperature was 57 degrees? No, because between noon and 6 o'clock at night, the temperature itself has went up and then come back down, right? So if this is 12 and this is 6 o'clock, there was some peak in here of temperature, of heating for the day that happened. How do we estimate that? Well, there's a cheater way of doing that. And this doesn't always work. In fact, I would argue that this works a little more than half the time. But it is a good place to start before you start poking into the data even further. We're not going to do that in this case. We're going to take this and run with it. But figuring out the afternoon high, a quick way to estimate it is you take the 0Z SKU-T and you're just going to pull that line dry adiabatically down to the surface. And once you do that, you get to about 21 degrees in here. Or, excuse me, 19 degrees. So I pulled that yellow line down too far. It gets you to about 19 degrees in here. Right there. Because your 20 degree line is right there. And that gets you about 66 degrees. You can see, hold on. This is a better look. There's your 20 degree line right there. Here's your surface line right there. So that gets you to about 19 degrees. What is 19 degrees? Well, it's about 66. Clear that out. It's about 66.2 degrees. Okay. So we're making a lot of assumptions here. And the biggest assumption that we're making... Hang tight. Hold on a second. I lost my video again. I tell you. The biggest assumption that we're making here is that, in fact... There we go. Okie dokie. Is that, in fact, the models are good and the atmosphere is perfect. And we know that both of those things are false. Okay. We're assuming, more specifically, that there isn't an inversion set up this day. That there wasn't a low-level cloud cover. And we can make that assumption pretty easily in here because all of the cloud cover, in this case, probably would have been high cloud cover, right? I mean, we're saturated up here, higher up into the atmosphere. We were a little bit earlier in the day as well. So we've probably got some high clouds in here, and it may be a mixture of cloud cover, but we probably don't have any low clouds in here or an inversion set up. And we're also assuming that we didn't get crazy peak heating and some super adiabatic feature near the surface, which shot the temperature up to 70 degrees. So we would say 66 degrees, some high cloud cover, again, high clouds, maybe mixed clouds, partly sunny, mostly cloudy, depending on how you wanted to call it. I would call this high clouds, which are probably blocking out most of the sun. So you could probably call this mostly cloudy. And you would say about 66 degrees. Okay? The Amarillo forecast for that day was high clouds, making it partly sunny. Afternoon temperatures in the mid to upper 60s. No chance for rain. Wind out of the southwest at 15 to 25 miles an hour. That was direct from the National Weather Service on that day. And we could pick out the wind. By the way, we forgot to do this. I apologize. But you can pick out the wind here, right there. Out of the southwest at 15 knots, dying to about 10 knots. And what does that give you? 15 to 25 probably in between. Before I let you guys out of here, we're going to take a quick break. It's been 15 minutes. So a quick break, and then clear that out. Then we're going to talk about snow. So 5 seconds here to get a drink of water. I'll take a swig of my Dr. Pepper here. And let you guys kind of pause for the cause for a moment. And then we're gonna have a brief conversation. It's gonna be very brief. A brief conversation. There we go. About snow. Very brief. Because I know people love snow. Okay. So making snowflakes is different than making raindrops. Snow is made when you saturate the dendritic growth zone, the DGZ. It's roughly between 12 and 18 degrees below zero at any altitude. The column of air must be below freezing from basically top to almost bottom. And the forcing mechanism for creating snowfall is different than creating rainfall. This is where I've been saying that omega is going to come in it's going to be helpful later in this class. Here's your example. So once the forecast is almost complete, in your forecasting, you're trying to figure out if snow is going to fall and you're in the south. Finding the DGZ is important. You can do this on one of the soundings from Pivotal Weather. And what you're going to do is you're going to try and find that thing right there. And that's going to be your dendritic growth zone. It's going to give you an altitude for that. And it's going to line up kind of on the right-hand side here. And you can follow this line basically straight over. So you would say, okay, what's happening within that dendritic growth zone on the sounding? In this case, it's saturated between about 11,500 feet and about 14,500 feet, give or take. And in this case, there is also omega. We've got some forcing happening in there, warm air advection. Not necessarily forcing, but it's kind of forcing and warm air advection. It's not one thing or the other. In this case, you've got something similar. In this case, though, there it is, but it's very dry. And there's not really any omega happening. And so I would argue that you're probably not going to see snow. Now, here's the interesting part about this, is there's your freezing line right in there. So you may still see little ice crystals. You know, you've got a little bit happening a little bit closer to the surface. This happens down here, and that's actually where this is pulled from. This happens down here all the time. Once a year in the winter, we get this. You get a very shallow layer of very cold air. I mean, the temperature is 20 degrees. My goodness, it's chilly. And you've got saturation, and then on top of that, you've also got some semblance of warm air advection, or some kind of advection happening within a saturated layer of the atmosphere below the dendritic growth zone. In that, you can still get things to precipitate out of the air. It's usually these little tiny ice crystals. But it's not technically snowfall. It's not real snow. Little ice crystals. So, what we got to do, in this case, we'll go back to the original case. We're talking about the day before Christmas in 2017. We're looking out 288 hours. 288 hours. How many days is that? That is 12 days. No. 11 days. No, 12 days. I had that right. Okay. Yeah. Math. All right. So you're looking 12 days out in the future, just for funsies, to see, is it going to snow in Hattiesburg and the Gulf Coast on Christmas Eve, just in time for Santa to arrive. All right, we've got our saturated dendritic growth zone. It's good and saturated. We also have some omega. We've got some forcing. That means this forecast model is suggesting that snowfall is a possibility. However, we got to go back to our line here, our freezing line. There it is, right there. And look at how much of the column of air is above freezing. Here's another thing that happens down here all the time. You can't get snowflakes to stay snowflaked all the way to the ground. We can make them all we want up here. We can make them and make snowflakes, and we're just pile driving the snowflakes down to the surface. The problem is it's got to run through all of this very warm air before it gets down to the surface. It melts all the snowflakes, then they're gone. In this particular case, 12 days out, it was suggesting that the temperature would be back down to around or below freezing near the surface. That would give us sleet. In this particular case, I don't recall or not, but I'm pretty sure that no one saw sleet on Christmas Eve in 2017. The reason, because we're looking too far out in the future, and like I was saying in the modeling lecture just a couple of lectures ago, that these models are not perfect, and they do not do a great job the further and further out into the future you look. And here's a perfect example, calling for something that definitely did not happen. Now, how about this situation? Some of you may or may not remember the day that it snowed here back in, what would that have been, in December. Hey, there I am. In December of 2017, December 8th. And this was a forecast that everybody airballed. We all missed this one. And why did we miss it? Well, this is kind of what we were looking at. Here's your freezing line right in here. And remember that wet bulb that we were talking about? See that little blue hatched thing? That's the wet bulb. And remember, the wet bulb temperature is if you were to cool the temperature back, if you were to instantaneously shove all the moisture you can in there, what would it cool the temperature of the atmosphere down to? Well, in this case, the wet bulb is just on the back side of the freezing line. The temperature is just on the warm side of the freezing line. And so what ended up happening is we had all this snow up here. It fell into that barely drying enough air in order to pull the temperature back over the freezing line. It saturated the air, pulled the temperature back over the freezing line, and then it started snowing. And then what ended up happening is because we had omega within the dendritic growth zone, and that didn't change because we had a southwest flow aloft, we kept on injecting warm, moist air, well, warmer, moist air into the same area, creating more snowflakes, snowing those snowflakes out, continuing to saturate the air, pulling the temperature back, and pushing all those snowflakes down to the surface, where the surface temperature was running right at or just below freezing, allowing the snow to pile up. How often does this happen in South Mississippi? Not very. In fact, that was probably a once in a 20 or a 30-year event. So there's your quick note on snowfall, because I know everybody likes to see snow down here, as well as walking you guys through a quick forecast. That is all the time we've got today. We're going to pick up things next lecture with more weather forecasting stuff. We'll go over a couple more weather forecasts as well. I'll walk you guys through some things, and then we'll get you guys going on some of the weather forecasting exercises in the coming days. And then pretty soon we'll be done with the lectures, and all we'll be doing is those weather forecasts.